Hello students, welcome back to another live session, and you must have seen the topic already. We are going to discuss about polynomials. This is one of the most important topics you have in class 10, and a lot of students struggle with it. I have managed to get 15 different questions from polynomials. Usually, if you'll see the pattern, polynomial questions this current years, they're not coming for like big marks, okay? And most of them are one mark questions, and sometimes you do have 2 mark to 3 mark questions. So the overall topic you can expect to be of about 5 marks, okay? Algebra is one of the whole chunk of algebra is the highest mark scoring topic. You have the highest percentage of questions coming from all of algebra. So polynomials do fall under algebra, and it's the first topic in algebra that you have. I am assuming that you must have started this already in your school, and some of you know how to deal with questions, and some of you, still knowing the concept, might struggle with certain type of questions. I have tried my best to collect many 1 mark questions which can be very different from each other. And hello Rohit, welcome back. Alan, welcome back. We are going to study about polynomials. Please tell me what's your remark on this topic. Like, how do you find this topic? Easy or something that does not make sense? Please let me know. And I am very certain that if you'll do these 15 questions with me today, your polynomial overall will be good. Like, you don't have to deal with any problems further, because the type of questions I have, I will begin with the basic kind of questions, and then I'll just challenge you with every new question, okay? So, hi, we have, yes, all right, 100 marks target. I wish the same for everyone. It's kind of possible in mathematics that you get that 100 marks. And from polynomials, as I mentioned, there is just like 5 to 6 marks of question. I think mostly they just say it's 5 marks, okay? You might have 3 1 mark questions and followed by 2 mark question, which could be 1, okay? And I think apart from that, you will come across some questions. Sometimes they can give you 3 mark question, okay? Come on, 100 out of 1,000, that's just 10% you're thinking about. Don't think so low, right? I mean, if that is what you're saying, regarding what you know in polynomials, well, I think I can help you. And I just hope that with these questions, you don't have to deal with polynomial problems ever. That is my target. So, without wasting much time, let's see some of the basic questions. And as I said, I will move on to higher question one by one. For each question, you can have a notebook by yourself, and you can try using a notebook. A lot of questions can be done without a notebook as well. So, you can just respond, okay? All right, let's start. Rohit, don't worry about internal marks. Just focus on the main exam, and internal now, I think it's pretty much gone. There is nothing you can do about your internals now, I guess. Yeah, because they have already, I think the marks are already settled in that case. So just give your best in the finals. That is my advice, okay? Because it is really interesting. The topic is really interesting. All right. Let's see what the first question is. And I know a lot of you will be able to answer the first question, okay? Let's hope that you will answer me. All right. Oh, I can't see. Okay. So this is the first question. This is the basic kind of question. They come for multiple choice. I have not given the options because, you know, I think you can do it even without the options. So they give you to find a quadratic polynomial, the sum of whose zeros is -5 and the product is 6. So it's really interesting that finding the quadratic is much, opposite to what you have been doing for solving quadratic, right? For solving the quadratic, you factorize and then you get the roots or the zeros. So here, in this case, the zeros are given, or the connection between zeros are given to you, and you are supposed to write the quadratic polynomial. So now remember that concept when you used to factorize, you used to take the middle term, yeah? So they would ask you something, x squared plus 5x plus 6. Then what you would do is you would always solve it by taking the middle term as the sum of the two terms. You would split the middle term into two terms such that their product is equal to the last term while the sum is exactly equal to the middle term. So we are also trying to do the same thing because the zeros are given to us as -5. The sum of zeros is given to us as -5. This -5 always contributes towards making your middle term. Okay, now I want you to remember one thing, because you know that if I ask you to factorize 6, you would tell me 2 times 3 is 6 and 2 plus 3 is 5. So the two factors you would get here would be x plus 2 and x plus 3. Okay, and now when you were solving it, or when you had to say what are the zeros here, the zeros are exactly the value that makes each bracket 0. So this bracket becomes 0 at -2, which is just the opposite of this, and +3, the opposite of that is -3. So these are the two zero values, right? So we look at the same thing. We take the sum is given to us as -5. So you just have a look here. Their sum is -5, but the number that is expressed in the equation is just the opposite of what the sum is. So that is the reason why we say that the sum of zeros, when given to you in one sign, to write it into the equation, you have to reverse the sign. That is the reason. Now for product, it really does not make a difference, because even if you take -2 times -3, it's going to give you +6. Even if you take +2 times +3, it's going to give you +6. So that is the reason why for product, we really don't have to think about changing the sign. So that is the reason we have the formula that the sum of zeros when given to you. So here the sum of zeros is -5. In that case, the coefficient, the second coefficient simply has to be the opposite of -5. So quadratic is written in the form of ax squared plus bx plus c, right? And now remember that this value of a, when it is there in the equation, then the way we find the product is by multiplying a with c, right? So in order to make the equation all in terms of the leading coefficient 1, you want to divide all terms by a, okay? And that is the reason now the sum is always represented by b upon a. The negative, the sum is given to you here as -5, so you would take opposite of -5, which is 5. That gives you the x term, and the product here is 6, so I'll just write that as +6. And now my first term here, because we are saying that the first term, we are just taking, they have not given you as a fraction, nothing like that, so it's very clear that this value of a is 1, okay? And that is the reason why my x squared term remains as it is, x squared plus 5x plus 6. This is the quadratic that you can form with zeros, where the sum of zeros is -5 and the product is 6. I hope that has made sense to whoever who have not understood the topic before. It is just simply opposite of factorization. All right, so Rohit has got his answer, and Kakrot Edit 654, your answer is actually right. Now the fact is, to this quadratic you have obtained, you can actually multiply by any value outside, okay? But usually they'll just give you the options with this part mainly. So you can ignore this value of k. You don't have to necessarily write this because the options might just give you in form of x squared minus 5x minus 6 or x squared plus 5x minus 6. There will be options like that. We have to consider this value of k only if I want to consider multiple polynomials using the same roots. So note that for this polynomial, it's not that the only polynomial where the sum of zeros is minus 5 and product is 6 is only this. This is not true, okay? This is the basic quadratic. But if I multiply this by any value outside, it can be a fraction, decimal, I multiply with anything, the quadratic will still give me the same zeros whose product will be 6 and the sum will be minus 5. So yes, your answer is correct, definitely. Now, this is the first question, and I already told you I'm beginning with the easy questions, right? So this is the basic kind of question they ask you from quadratic. Moving on to the next question, I am very hopeful that some of you can do this question again. If not, I'm here to help. If one of the zeros of the quadratic is 2, then the value of k is dash. So now, this is also an easy question. K here is just a constant, okay? K is a constant here. Now, right now, I told you that constant is connected to what? The product of the roots, yeah? When you have two roots, then their product is always equal to constant divided by the coefficient of x squared, which is 1 here, so I can just ignore that, okay? And now, because I have been told that the value of one of the zeros is 2. So now when you know one of the value is 2, what you can do? Now, obviously, one of the zeros has been given to you, but the fact is you really cannot find out k because your other zero is unknown. So what could be the approach here? What you'll do is understand the meaning of the word 0. 0 basically means the whole equation will become 0 when I'll plug in the value of x as 2. So what I'm going to do is into this polynomial given to me, I will go ahead and plug in x as 2 because I'm very confident from the question that this polynomial will become 0. So if I say this is px is equals to x squared plus 3x plus k, then question has told me that this polynomial will become 0 at 2, at x is equals to 2. So I have to solve the equation p2 equals to 0, as in plug in 2 into the expression here. So it's 2 squared plus 3 times 2 plus k should be equal to 0. Yeah? And I think it's pretty simple. 2 squared is 4 plus 6 is 10 plus k has to be 0. Clearly, k has to be opposite of 10, which is negative 10. Yes, this is how exactly we would approach questions like this, and pretty simple, yeah? This is again, I'm saying these are your basic questions. So the last remaining, like the last 4 or 5 questions can be tricky, so I want to level up, you know, steadily. That is what I can say. All right, I hope that made sense. Rohit has already answered. If somebody wants to understand any part of the topic conceptually, please let me know. That's great, Alan. This is one of the topic you have in your competitive exams as well. Like they ask you questions. They'll not call polynomials. They'll just call algebra, and inside algebra there will be questions where they want you to write equations, okay? There will be questions where very much similar to this. I mean, once you'll go and see your syllabus from algebra, you will come across questions like this. So you will be, you know, learning a lot from these sessions. All right. That is it. I want to move on to the third question. Now, third question is asking me something really interesting. I have given the options here because the options do play a role. I mean, without the options, I would have got a different answer, and the answer that I'm getting might not be in the options directly. So let's see what the question is. The question wants you to find out which of the given polynomial, quadratic polynomial, has the zeros -2 upon 3 and 2 upon 3. First of all, when the zeros are given to you and you want to figure out a quadratic, you want to find the sum of zeros. So in this case, the sum of zeros will be how much? Alpha. I'm saying the zeros are alpha and beta, so the zeros will sum up to 0 again. Yeah, that's easy. Why? Because the values given to me are just equal and opposite. So when the sum is 0, what does that mean? When sum of zeros is 0, it clearly tells me that the middle term is 0, or there exists no middle term, because 0x, if I have to write the middle term as, it just becomes 0. Yeah, so it's very clear to me that my middle term is 0, or I don't have that x term in my quadratic. Okay, and now after you find the sum, you will find the product alpha beta, which is equal to -2/3 times 2/3. Definitely one number negative, the product will be negative, because one number, when you are multiplying two oppositely valued numbers, the product is always negative. So thereby the product has to be -4 upon 9. Correct? And now to find the quadratic, what will I do? I will just have to consider. I hope you are able to see the question. All right. The quadratic here will simply be x squared minus, as I told you, 0x is, the 0 term is not there, or I can just write it 0, so I'll ignore writing that x term, okay, because the sum is 0. Now the product term is something I can write it after the x squared term directly. X squared minus 4 by 9 has to be my quadratic, but you see you don't have that option clearly, right? So what will I do is, when I see one fraction, I can bring out 1 by 9 outside as a common factor. Then obviously if I have brought 1 by 9 outside, then I have to make sure that this x squared has been multiplied by 9. Then only I can take it out. I can say that this becomes x squared becomes 1, right? What we are doing is we are factorizing this 1/9 outside, or you can say that you are taking out the fractional part out. To keep the fractional part out, you want to multiply any number without that fraction, simply goes and multiplies with the top. 9x squared, it becomes -4. I hope this made sense. All I did is, now you can see 1/9 upon 1/9 times 9 is what gives me 1 here, the original value. So once I'll write it like this, then it simply becomes, okay, it simply becomes what? 9x squared minus 4 is inside, and then I have this 1/9 outside. So clearly the quadratic, the only quadratic without the constant, if I have to write it, then it just becomes 9x minus 4. Okay, so you can always consider that. The fact is, you see this 9x squared minus 4 is the main quadratic part multiplied by the constant 1/9. Now out of all the options you have, which of the option tells you this? Only option 4. And now option 4 has 5 multiplied here. What does that make? How does that make sense is, as I told you, the main quadratic is just 9x squared minus 4. Now this constant here just not have to be 1/9. It can be anything. Okay, it can be any constant. This value here can be anything. It can be a number, it can be a fraction, decimal, anything. So because even if I put 5 here, then what happens is, it is still giving me the same quadratic. It's not giving me something else, okay? Because the fact is, when you solve for a quadratic, you always solve it equal to 0. So even if you think about putting equal to 0 here, this 1/9 just goes to the other side to become 0. So the only quadratic was 9x squared minus 4. So you multiply that by any value, it just becomes, or it remains the same quadratic, giving you the same zeros. I hope that made sense. All right, option 4 is correct, Rohit, and that is something. You already told me the topic is easy for you, so yes, I am hopeful that you will answer me at least 10-12 questions here, okay, even all 15. But we have some questions. The last 4 questions are not 1 mark. They are just 2 marks or even 3 mark questions, mostly 3 marks, okay? So, but in the recent papers, you'll see that they are mostly asking 1 mark questions. Like you have 3 questions from polynomials, all 1 marked. That is the pattern I saw. And in one of the paper, I saw 2 mark question. And in one of the 2020, I guess, 2020 or 2021, that is when you had this 3 mark question. So you can expect a 3 mark question as well, because it's been a long time they have not asked, so they might just repeat the cycle, you know. So this is it. This is how you would approach a question like this. Even if the answer that you get in a quadratic is not in the option, you can still get that answer exactly by thinking that there could be a common multiplier like this. I hope that has made sense. If anything is not, please let me know. Moving on. Question 4. I really like these kind of questions. I initially used to struggle, or I never really know how exactly we could approach these questions. And now the question is just for 1 mark. So you want to be very efficient and you want to solve this as quickly as possible. If alpha beta are the zeros of a polynomial, then 1 by alpha plus 1 by beta equals to how much? This is really interesting. Why? Because they are asking me to find the value of 1 by alpha plus 1 by beta. Clearly, I know that this is a fraction, 2 unlike fractions, so I make them like fraction first, or I want to make their denominators common. Obviously, to make the denominators common, I multiply each of the fraction with the opposite denominator, giving me alpha beta as the common denominator. This alpha needs to be multiplied by beta, so both numerator and denominator has to be multiplied by beta like this. So it becomes beta plus alpha at the top. I hope that made sense, yeah? And what you're really doing is alpha plus beta or beta plus alpha. Addition is commutative, we call in mathematics. Commutative means you write it a plus b or b plus a. It's the same thing. So what we really need is to find the value of alpha plus beta divided by alpha beta. That is what is equivalent to finding the sum of the reciprocals of the roots of the given polynomial. So from the given polynomial, we'll go ahead and find out what is alpha plus beta. Clearly, alpha plus beta here is the negative coefficient of x upon the coefficient of x squared. So here clearly the sum is given to me as, the middle term is plus 1. The sum is always taken opposite of what value you get. So alpha plus beta is minus 1 and alpha beta is again minus 1. So all I'm doing is just taking the ratio, I'm dividing the two values here. So clearly the answer has to be 1. Wow, this question was in my unit paper. Which one? Question 4 are you talking about? I want you to be prepared for questions like this. Questions where they relate the roots or they ask you to do something with the roots. This kind of question, this is how they challenge you from polynomials. Okay, and I hope this has made sense to you so far. And we are leveling up with each question, as I said. Some of the questions, there are some graph questions. So question 5 is from a graph. This kind of question, it's kind of easy, sometimes can be tricky to some students, okay? Question is asking you to find the number of zeros of px where the graph of px is given to you. Now, remember before studying quadratics, you used to study linear equation. That's the first level algebra we study, yeah? Solving linear equation. Because linear equations, they represent a straight line. But not everything moves in a straight line. If you look around things, you don't have straight lines only, yeah? You see things in the form of curve, like this parabola. This shape is now called parabola. It represents all quadratic equations, okay? Then what is the question asking you to find? The number of zeros. Now, what is the number of zeros here? Graphically, if I have to tell you, then zeros are basically the x-intercepts. Zeros are that value of x plugging on into the equation. The whole equation becomes 0. Graphically, they are your x-intercepts, because at x-intercepts, your y value will be 0, right? So that makes sense. You are supposed to look at the number of x-intercepts. Clearly, the standard way you see a quadratic is mostly intercepting your x-axis at 2 points. That is the reason why we have two answers for a quadratic, okay? But here the graph given to you has just touched one of the point on the x-axis, just one. Had there been 2 points, then we would have said, or we would have seen a graph like this, okay? Sometimes the graph will not intersect the x-axis at all. It will turn before it meets the x-axis. Then this is the example of having no zeros. This, the other diagram that I have considered here, exactly has 2 zeros, okay? Because zeros are just graphically, it's so easy to look at zeros. All you do is you see the number of times the graph has intersected the x-axis. And in this particular question, it's just touching the x-axis, and the moment it touches the x-axis, it has turned down. So clearly 1, 0. Now, if I'll ask you, when is this scenario possible? When do you have 1, 0 for a quadratic? Let's say, for example, if you are solving x minus 3 the whole square, or let's say you are solving something easy, like for example, if you are solving x squared equals to 0, yeah? If you are solving, or you just solving x minus 3 the whole square equals to 0. Then you have only one answer here, because the square root of 0 is only 0, so x has to be 3. So this kind of questions tell you that this quadratic, though a quadratic is always expected to have 2 zeros, that's the maximum number of zeros a quadratic can have. But for certain scenarios like this example I gave you, definitely there is only 1, 0, and this is how the curve will look like, okay? Definitely you know, the curve has to face upward like this if it was you know, x minus 3 equals to 0. But you see, this is another example of how there is only 1, 0 present here. Yes, Rohit, the graph of y equals to px means what? So first of all, graph of y is equals to px. So understand one thing, graph is all about comparing two things, x and y, okay? So we have a quadratic here, x squared plus 3x plus 4, let's say, or x squared plus 3x minus 4. Then what happens is, you will say that when you are solving a quadratic, you are saying this is equal to 0. So what you are doing is, this side you are plugging in different values of x, and if you plug in different values of x, you get different values of y, okay? So just like, for example, you know, if I'll plug in x as 4 here, then what will it be? X as positive 4. If I'll plug in, then, or negative 4, let's try for negative 4 first. If I plug in x as negative 4, this becomes positive 16, this becomes negative 12, negative 4, which will give me 0, right? So this point comes on the graph, negative 4 comma 0 will come on the graph. Similarly, I plug in different values of x, I'll get different values on the other side. I'll not get 0 every time. Solving is only when we solve it equal to 0. So logically, what is it all about? A graph of y equals to px means basically your x values are your input. With different input values, you get different output other side, right? And if you were to graph it, you would always get a graph like this parabola. You would always get a graph either facing upward, either facing downward. Now you will study in your coming classes why or when does a graph face upward or downward, and a lot more. But the graph of y equals to px just means that you have, because they have given you graphically, right? They have not given you equal to 0 here. That 0 is simply the value of y. Why do you think that 0 is the value of y? Because upon plugging in some value of x, the whole equation becomes 0. So that value which makes the whole quadratic 0 is now the x-intercept, and its respective value is 0. So that is the reason it has become the x-intercept, because any point lying on the x-axis will always have the y-coordinate 0. But if you plug in something like 2, then you will not get 0, you will get something else. But that point does fall on the curve, the quadratic curve. Just like you used to draw a linear equation with different points, remember? You used to do what? You used to take y one side, and then you have 2x plus 3. They would give you a linear equation like this. So even this can be written as y equals to fx, or y equals to px. Basically, it means y equals to px actually represents just the relation between x and y. It's nothing that has to really catch your attention as of now, okay, because it just means that it's a graph. When you're graphing, you're always graphing x and y values. You're not graphing x alone. If you were to graph x alone, then you would be graphing on a number line, not on the Cartesian plane, yeah, because number line has only one dimension. It shows only one dimension, x-axis, while a Cartesian plane shows you the relation between x and y, two variables. So y equals to px is just telling you that they have a graph where they are plotting different values of x and getting different values of y. That is the reason why you get a curve like this. Okay, that is the reason why you get a curve like this. And definitely a quadratic curve does not go in a straight line. It just follows this turning point, or it just turns at some point. That is the nature of quadratic. So that is what you want to understand. It is just about explaining, or the question is just telling you that this is a graph of a quadratic which is equal to some value of y, or for different x you will definitely get different values of y. Okay, it's not that every time you are getting 0. If you are getting 0, that means you are just getting the x-intercept of the graph and not the entire graph. I hope that made sense. Should we move to the next question? I hope so, yeah. And I can understand, Alan, you're saying you have to go back to your fundamentals. Definitely in your competitive exams, they're not going to ask you anything about, like binomial theorem or things like that, okay? They will just ask you all your basics, 8, 9, 10. Just remember these three classes, whatever you studied, that is going to be very useful, and that is what you have to understand. I mean, there is nothing more than that. Okay, if you have understood the part of 8, 9, 10, the syllabus of 8, 9, 10, you can try from different curriculum, and trust me, it's all in that only. There is nothing outside of that they'll ask you. So now let's move to question 6 and let's see what we have. I really like this kind of question again. You know, they talk about two zeros being the reciprocal of each other. What's so special about it when two zeros of the same quadratic, the two values which makes the quadratic 0, if they are reciprocals, reciprocal as in upside down of the other, right? If one 0 is reciprocal of the other, I want you to remember just one thing. If the two roots or two zeros are reciprocal, it just gives you something very interesting, and that's the product of the zeros will always be equal to 1, because we know in mathematics, any two things that are reciprocals of each other will always multiply to give you 1. So there is so less things to worry about for this kind of question. Okay, why? Because the zeros are reciprocal. I'm saying that zeros are alpha and 1 by alpha. These are 1 mark questions, so they are multiple choice questions. You don't have to show your working. All you really need to know is the product of the zeros will be equal to 1. In this case, for this given quadratic, I can represent the product of the polynomials by dividing the constant by the leading coefficient, which is 6 here. So I have to make sure I do not miss that, okay? Like dividing by the leading coefficient is not needed everywhere whenever the coefficient is 1, because you're just dividing by 1. But when it is something else, you have to consider, and you are very confident that their product has to be 1. Why? Because it's the reciprocal zeros. So just solve it, cross multiply. You see fraction one side, always cross multiply. That's like the simplest thing you can do. What plus 2 is equal to 6? K has to be 4. 4 plus 2 is 6, so definitely 4. It's such an easy question, but I know a lot of students will struggle to answer something like this. Okay, you're not alone. It is commonly, it's very hard for students to get into this, or they really miss the catch. Okay, but this is it. Whenever you see reciprocals, then there is always this concept coming into use. Okay, their product will always be equal to 1. If the product is given to you, if the constant term is given to you as something else, or yes, Rohit, you are right. Your answer is right. And this is, any question that talks about the zeros being reciprocal, this is how you have to approach, and this is the first thing that should come to your mind. The products of the reciprocals will be 1, okay? And it's a kind of question that has appeared in different forms, but asking you the same thing. They ask you that 2 zeros are reciprocals, and they'll give you a different quadratic. The approach method is exactly the same. So if you'll try a lot of questions with me right now, I am sure that one or two questions will definitely be the same in your pre-boards. I'm confident about that. As Rohit already mentioned that one of the questions was there in his unit test. Yeah. So I've tried my best to collect as many questions from polynomials. There was one year when I think during COVID or after COVID, the syllabus got much reduced, and that entire year the paper was just for 40 marks, and polynomials was completely deleted. Okay, and I think the children back then, they must have had a good time. Yeah, they didn't have to study this topic, and the paper was quite easy to see. I mean, the topics were less, and you will see the polynomial questions in every other paper except for 2021, if I'm not mistaken. Okay, so this is it. Question 6 was easy, right? Provided you will approach it exactly this way. Don't end up finding the zeros here, or just don't get confused with any part, except for knowing the fact that reciprocals, as in the product of the zeros, will be 1. As simple as that. I am moving to the next question. This question talks about, now this is again a kind of question that happens to stress out a lot of my students. If alpha and beta are the zeros of the quadratic polynomial ax square minus ax plus b, then the value of alpha square plus beta square is dash. I wonder why is this for 1 mark? It should have been for 2 marks, but there are many options given to you. It is a multiple choice question only, but I've omitted all the options. Okay, we will do it without the options. It's more fun. Now, it's very important to note that how do you get this alpha square and beta square? That is the main thing, right? Some of you might know the shortcut technique, some of you may not. So I'm going to stick to the basics, or I'll tell you what exactly you should do, but where is it coming from? That is also something you want to know. If I'll ask you alpha square and beta square, when do you see the square term for the first time? Like, imagine that in class 6, in grade 6, when you were starting algebra for the first time. In grade 6 itself, they might teach you in some curriculum they don't, okay? So the square terms appear when you are squaring, or you have that formula of alpha plus beta, something a plus b the whole square, right? So a plus b the whole square is always equal to a squared plus 2ab, which is very simple to remember. I think like 90% of the students who have understood, or they have studied math properly in grade 6 and 7, they know this, okay? This is the formula, right? This is when you see the square terms appearing for alpha and beta in the added form. So what you can do is, if the question ever tells you to find something like a squared plus b squared, you can always go ahead and write that. You just want to remove this term to the other side. So remember, alpha square plus beta square can always be written as alpha plus beta the whole squared minus twice alpha beta. Okay, now why? Because I know from a given quadratic, I am very confident to find out the sum of zeros and the product of zeros. So this is sum of zeros, alpha and beta, and this is the product of zeros. So all I really need is the sum and the product of zeros. I'll go back to the equation. I will find out what the sum is. So alpha plus beta has to be equal to the negative coefficient of x divided by the coefficient of x square, which is simply negative of negative a, is just a upon 1. I'll ignore that. Alpha beta is equal to the product term divided by the leading coefficient 1, so just b. I got the two values, just put the value and get the answer. So alpha square plus beta square is simply the square of the sum, which is A I got. So I'll square the sum minus twice the product, which is B here. So twice of B is 2B. I just got the answer A square minus 2B without having to take much time. And this is exactly what you should do. Remember this identity. Whenever you see A square plus B square, you don't have to do this every time. This is just for your understanding, provided you didn't know this before. So likewise, sometimes they might ask you for alpha minus beta, or if you have the value of alpha minus beta and you want to find the value of alpha square plus beta square, you would again think of the identity only. Okay, alpha minus beta the whole square. If you ever have the value of alpha minus beta, in some cases they might tell you the difference of zeros is something, then you can always use the identity alpha square minus twice the alpha beta plus beta square. So if I have to take just the square of the two zeros, then all I have to do is, when I have this difference, then square the difference and add twice the value of the product. Hi, we have someone new joined. All right. Piyush Kumar is back asking the same question, why trigger is important. Well, we are studying polynomials today, and polynomials, I think you are in class 9 and you have already started polynomials. I believe you have understood all sort of theorems, okay, factor theorem, remainder theorem and all. And I want you to be prepared for a topic like this. Polynomial, it's just a continuation of what you have started in class 9. All right, let's continue with the next question. We are done with this question. We found our answer. It's A square minus 2B. Yes, Alan, I have actually, my shots are based on questions from SSC and CGL. Okay, I have tried a lot of questions from those papers. I have tried questions from UPSC CSAT, because I see so much connection with what I'm teaching in school. Okay, I see that things are almost the same. They just want you to approach it in a way that you can get things quickly. Okay, and the syllabus is still the same. So yes, I have done it, and I am trying my best to come live another session for competitive exams. I am trying for algebra and a lot of topics like time and work, speed, percentage, everything. Yeah, so yes, I will keep that in mind, and I will make sure that you will get to know better with all these topics. I hope to make you confident, definitely. So all right, Rishank, welcome, and I hope you will study, you will get a lot to know about this topic, polynomials. All right, let's move on to the next question, which is question number 8. Again, question has told you that one zero of the polynomial is twice the other. Now, if one zero is twice the other, then I know what I have to consider. My zeros will simply be alpha. If one of them is alpha, then other has to be 2 alpha, okay, because of being double. So if one of them is alpha, then the other one is 2 alpha. Question tells you, or it has given you the polynomial. So what will I do is, for the given polynomial, I'll go ahead and find the sum of roots. So here in this case, the sum of roots will simply be the negative coefficient of x. Now note that when I say coefficient of x, it's not just minus 3, it has to be this missing value k, because they have told me that there is something multiplied along with that minus 3 to give you the coefficient of x. So coefficient of x means ignore x and write everything as the coefficient, okay. So now the sum of zeros, as I told you, it's always the opposite coefficient of x. So I have to write it as 3k. That's the sum Okay, now in this case I am summing up alpha and 2 alpha. I don't have beta. Okay, they are not two different values, just double of the other. So I'll just write down alpha plus 2 alpha has to be equal to 3k, gives me 3 alpha equals to 3k, which means I can divide both sides by 3, giving me alpha is equal to k. Okay, now obviously I'm finding the value of k and I don't know alpha yet, so I cannot stop here. I have one thing to look ahead, which is I'll take the product. So I'll say that the product of the roots here will simply be alpha times twice alpha, which has to be 2 alpha squared. And now the product of the roots is always given by the constant term. The constant term is not 4 alone, it's 4k. Okay, so I'll go ahead and write down 4k. So find the value of k. Question is asking me to find the value of k. So I can write this as alpha square equals to divide both sides by 2 gives me 2k. Now note that we are finding k, so I can remove this alpha, and instead of alpha I know alpha is equal to k. I got that from the previous equation or from the previous information that I had, right? So sum of roots, I took that as 3 alpha, which is equivalent to the negative coefficient of x. That gives me alpha equals to k. I will plug it into the equation where I am equating the products of the roots. So the product of the roots will be 2 alpha square here, and instead of alpha I will plug in k. That is what the other equation told me to do. K square equals to 2k. Now at this moment what happens is a lot of my students will divide by k again. Okay, but that is not valid. Remember, this is something you should never consider, dividing by the unknown value. Why? Because what happens is the unknown can also be 0, and the fact is dividing by 0 is so invalid. It's like it gives you math error, right? Dividing by 0 is not possible. So in order to solve an equation like this, always bring the terms one side. Okay, always bring it one side. So you'll write it as k square minus 2k equals to 0, and then factorize k outside, giving you k times minus 2, or k minus 2 is equal to 0. K times k minus 2 is equal to 0. Thereby I have two possible values for k. This outside value, either k is equal to 0 or this bracket k minus 2 is equal to 0. So we have two answers from here. K is equals to 0, k equals to 2. Okay, because 1 0 is twice the other, then obviously I just found out that the value of k here can simply be equal to just 0. Yeah, that is what I have done, and I divided. Yes, everything is fine. So I had k value both sides, and now these are the two possible values of k. K is equals to 0 or k is equals to 2. Perfect. These are the two possible values. So sometimes if you have this question as a multiple choice, they might give you both options in the same answer. They will not give you two different options for k, okay? Or they might just give you k as 2. Alright, they might just ignore k as 0, because that might make my quadratic very simple, just k like x square. Okay, alright, I'll take that as a feedback, and I will make sure that I will conduct a class for multiple chapters. I will do that. In fact, I did do it. The first 2 live classes were based on multiple topics, okay, but I figured out somehow that not everyone would have been interested, so that is the reason I started moving to chapter wise. But definitely I will want to, as you mentioned, your pre-board start from 15th of December, so I will try my best before that. If you have any suggestions like this particular topic, please let me know, because I know if it is even useful to one person, it does make a count, right? So please go ahead and tell me the topics you want me to do, and I will discuss the same thing for you. I think after doing polynomials today, I don't think you would need polynomials again. So most probably we might deal with the other topics. I'm very hopeful that you will not need any help for polynomials further, because I have sorted out all the type of questions from this topic. Okay, moving on to question number 9. Question number 9 is again for 1 marks, and as I told you, just be prepared. Okay, polynomials, you can expect 1 mark questions, like 3 of them at least can be 1 mark questions, and 1 of them could be 2 mark or 3 mark questions. Okay, so just I know that is how I can give you a blueprint of the type of questions you could have. There won't be any 4 mark questions from polynomials because the current syllabus has removed the part which actually asked you 4 mark questions before. Okay, that division algorithm thing, you don't have to do that now. So that is the reason why you don't have to expect much of 4 mark question, but you can't be like 100% sure about it, so it's up to them. But for your pre-boards, I'm kind of confident that there might not be just a 4 mark question. Okay, Rohit, you have problem with case-based questions for statistics. All right, I don't think it's really a problem, but yeah, I think if you want me to discuss that, definitely I'll do that. Okay, any more topics, circles, triangles, anything, just let me know. Till then, I'll move to the next question and I'll come back to your message. Okay, question number 9. Alpha and beta are the zeros of the polynomial, and alpha plus beta is equal to alpha beta is equal to 10. Now this is the main important, this is the main important information, the resource of the question. Okay, they want you to find the value of a and c. You have 2 variables missing, and they have just given you the relation between the sum and the product of the roots. Both are equal to 10. Nice. Again, just stick to the main things that you have studied in this topic. Think about the sum of zeros. Sum of zeros is always equal to negative coefficient of x upon the coefficient of x square, which is a here, and negative of negative 5 is 5, so I get 5 upon a. Question has told me that this is both equal to positive 10, right? So I will plug this value as 10. I want to find the value of a. A is at the bottom, denominator. So you want to bring denominator to the top, then just swap the position for a and 10. So a is simply 5 upon 10. I think you know this, yeah? You can always swap position for a numerator and denominator present in that cross multiplying position. Okay, so a has to be 5 upon 10, so a has to be half. We got the first value, a. And now I will think about the product of roots. Product of roots as in, I know alpha beta, which is equal to 10 here. According to the given equation, alpha beta can be represented by the ratio of the constant to the coefficient of x square, which has to be equal to 10. So c equals to 10 times a, right? So I have the value of a is equals to half, so I will just plug in c equals to 10 times half. Half of 10 is how much? 5. So I will just be quick with that, and I just got the answer for the 2 variables without having to waste much time. All right, pretty simple, yeah? Question 9 was simple, I would say that, though it looked complex because there were 2 variables missing, and sometimes 2 variables missing, you need always 2 equations. You had 2 equations already, right? And one equation gave me one value at a time. So obviously the product part, if you would have solved that first, then you would have got an equation connecting a and c. You would not have got the value of either, because both were missing. But because we used the sum before and the sum has only one variable present, I found that value. I plugged it into the next equation. All right, that's it. That is how you can be quick with a question like this. And moving on to the next question. I like these kind of questions where all these roots are present and it makes things look so complex, but more complex sometimes they look, more easy they could be. Okay, so again, finding a quadratic polynomial, they have the roots given to you. when the two roots are given, always take their sum and the product to find a quadratic. Okay, so their sum of roots will simply be, you know, these terms can be added up, but you clearly see that they are conjugates as in for irrational numbers a plus b and a minus b, or one of them is a root, then they always form conjugates. I'll show you why conjugate. Upon adding them, you got rid of the root part, giving you that the sum here is 4, while to take the product you have the two terms in the form of a plus b and a minus b. Now why did I call it conjugates? Because upon multiplying the two conjugates, you're rationalizing the number, meaning you have a plus b times a minus b, which is a squared minus b squared. Square of 2 is 4, square of root 3 is 3, a squared minus b squared. So I just found that the product of the roots here is simply 1. Okay, the reason why I call them conjugates is because when you multiply the conjugates together, you get a rational number. They were irrational, two irrationals. It's not every time that two irrational they multiply to give you a rational value, but if you multiply conjugates, you will always get the rational value like this. Okay, and that is the reason why we use them to rationalize denominator. So once we have the sum, we have the product, you know what to do. Take the quadratic, x square, it is always in the form where x square leading coefficient is always 1, we take it, right? And then the sum you got is positive. You don't take the sum as it is, you take in the equation, you have to take it opposite to what you have got. So it will be minus 4x plus 1, the product will always be in the same quadratic polynomial you're writing. So yes, you can say that this is px equals to x square minus 4x plus 1. All right, nice. Now I have the last 1 mark question. Can you tell me this answer? The number of polynomials having zeros 1 and 2 is dash. How many polynomials can have this 0, 1 and 2? If I was to find a quadratic, I would get one quadratic. But remember, I told you in the first question only, you have, you are free to choose a quadratic multiplier, a multiplier at the front which multiplies all the terms in a quadratic, can give you different quadratics. Yeah, it can give you different quadratics with the same roots. So thereby, remember that though the sum of zeros and product is fixed, you just don't have many or all you don't have just one quadratic. You are right, it is infinite. Okay, the number of polynomials you have or you can form with the number of zeros you have, it's infinite, many. Okay, so yes, the answer is infinite. So this was the last last 1 mark question. After this, what I have, they are all the next one following is a 2 mark question. The rest 3 of them will be 3 marks each. All right, moving on to question 12. This was also in my unit test. See, I'm so happy to know that questions are not just something I have randomly chosen. It's like you have seen it before, or in circles where a triangle is involved. Definitely. Did that question come already, or do you have problems with question like that? What do you mean? Let me know. All right. You have a chance to score full marks for your pre-boards, okay? I'm hoping you will get. Let's start with question 12 now. Again, this question says 1 0 is reciprocal of the other. I told you. Now, this is the thing, right? Sometimes the same kind of question comes for 1 mark, and similar to that, it's a question for 2 marks now. No, for a question with, for a question like this, please go ahead and write down your steps, okay? Don't ever miss out that, because sometimes we may do some sort of silly mistakes in the final answer, and if it's there without the steps, you will lose everything. But if your steps are right and your approach is right, the examiner will understand that this person knows the concept. It's just that he has gone silly with one part. Okay, so you will still get the marks. I mean, not just full marks, but yes, the step marks will be there. So write down your steps for a question like this. 1, 0 is reciprocal of the other. I told you reciprocal means think about the product of zeros. So here the zeros will be, you can write the answer like this. Let the zeros be alpha and 1 by alpha. Yeah, because now we'll say product of zeros. Alpha times 1 by alpha. According to the question, product of zeros is always obtained by taking the negative coefficient. Sorry, not the negative, the constant term will be taken in the same sign. That is my product term. And note that here the leading coefficient is something else, so I have to write it as it is, 6. Okay. The coefficient term is given in bracket with a negative sign outside, so don't ignore anything, just remember to put everything in your equation. Now product of zeros is clearly 1 here, so you will work out this. Upon solving this minus inside, your 2 becomes positive, k becomes negative. Upon 6 is equal to 1, cross multiply, 2 minus k is equal to 6. So 2 minus how much is 6? You can find that out by taking k to the other side to make it positive, while 6 comes this side with 2, making that 6 negative. So 2 minus 6, the answer is negative 4. 2 minus minus 4, definitely that is 6. So k equals to minus 4. This question must be for 2 marks because that bracket thing is given to you with a negative sign outside. So they just wanted to trick you, right? I guess that is the thing, because it's much similar to what I did before. But this is it. You don't need to go ahead and do anything about that sum part, okay? That is not needed. All right. So this is the kind of questions you can expect for, you know, small marks like 1 or 2 marks. This was just a 2-mark question. Before that, everything was 1-mark question. And now let's move on to the last 3 important questions of this topic. And once we are done with these, you can just sit back and do your revision. And I don't think you will struggle with any questions while you're revising this topic. So let's get started with the 3-mark questions now, okay? Question 13. Alpha and beta are the zeros of the quadratic polynomial. Find the quadratic equation whose roots are alpha square and beta square, okay? This is and. The roots are alpha square and beta square. Now, you know when do we get this alpha square and beta square? I have spoken of that already. So let's be careful. First of all, for the given quadratic, step 1 is what you'll do. You will take the quadratic given to you and find the sum of roots and product of roots or product of zeros. So let's do that. Step 1 is to take the quadratic equation given to you and extract all the information you need to find a new quadratic. Okay, so with the help of the given quadratic polynomial, I will say that the sum of zeros will simply be the negative coefficient of x, which is 7, divided by the coefficient of x square, which is 1. Ignore that. Now similarly, alpha beta is the product of the roots, again 10 upon 1, so 10. Now you want to find the quadratic equation whose roots are alpha square and beta square. Now if you want these to be the roots to form a quadratic equation, all you need is the sum of the roots, the product of the roots, right? So we will find the sum of the roots. So alpha square plus beta square, that's the sum. So sum of the roots, for the sum of squares, I showed you that formula. What you can do is you can take the square of the whole square of the sum of the two and minus twice alpha beta. Okay, because I showed you they are just the same formula, a plus b the whole square thing, right? So now I'll plug in Alpha plus beta value is 7, so 7 square minus 2 times 20. 7 square is 49 minus 20, 2 times 10, sorry. So 2 times 10 is 20, 49 minus 20, the answer is 29. I got the sum of roots here. Now likewise, I want to find the product of roots. How to find the product of roots? Here my roots of the new quadratic is alpha square and beta square. These are the roots. So I have to find their product. Two numbers indulged with the same power being multiplied. You can write them first, you can multiply them and give that common power. So thereby alpha beta, what is the product of roots? I have it from the previous equation, 10. So I have to plug in 10 square, which is equal to 100. Now to write a quadratic equation, every quadratic equation is written in the form of ax square plus bx plus c, or you take the sum, you make that as the middle term, and always don't forget that sum, whatever you get, you have to take the opposite of that. Just like you use the quadratic equation to find the sum, you converted that into negative, you have to consider the same thing while reversing the process. You want to put it into a quadratic or form a quadratic, then always take negative of what the sum is. So quadratic will be, you can write out k outside, that is simply a multiplier. You are saying that there can exist any multiplier to this main quadratic. The main quadratic is x square. Okay, the sum forms the middle term, so minus 29x, I took it opposite, plus 100. So the simplest value of k you can put is, so when k is equals to 1, okay, that is you can either ignore writing that k, that will also give you full marks. If you write along with k, no problem. All right, so the main basic quadratic, which will have the roots as alpha square and beta square, will simply be equal to x square minus 29x plus 100. They are asking for equation. Now this is very important. When they say quadratic equation, now this has to be equal to 0, right? Because that is how you write a quadratic equation, everything one side equals to 0. And now you can remove that k, thinking that it has gone to the other side, and 0 divided by k. So you can just write the quadratic x square minus 29x plus 100 equals to 0. Note that question did not ask quadratic polynomial. Question says quadratic equation. Don't just leave your expression, okay? You have to write it as an equation, means with equal to 0. How does that look? Is that easy? Rohit, your answer is correct, but because it was an equation, don't forget to write equal to 0. That is something you want to consider, okay? All right. Now, that is how a 3 marks question look like, right? That is the first 3 mark question I did, and I hope that made sense. And now, moving on to the next one. Find a quadratic polynomial whose zeros are reciprocals of the zeros of the given polynomial, where a is not equal to 0, c is not equal to 0. Now, question talks about reciprocals, but they have not told you that the zeros are reciprocals of each other. They have told you to find a quadratic whose zeros are reciprocals of the zeros of the polynomial. Well, for competitive exams and higher level, there is a shortcut way to approach this, or I'm going to tell you that, but firstly we'll have a look at how exactly we do it, okay? They have given you the quadratic ax square plus bx plus c, and now let's find the sum of zeros and product of zeros first. So sum of zeros will simply be equal to, because the quadratic is given in a standard form, this is a standard form of a quadratic, ax square plus bx plus c, I will write it as minus b upon a. Likewise, the product is simply c upon a, constant upon the leading coefficient. And now question wants me to find the quadratic polynomials whose zeros are reciprocals. So the new zeros will simply be 1 by a and 1 by alpha and 1 by beta. So all I really need to form a quadratic is the sum and the product. So my step 1 is to find the sum. Step 2 is to find the product. Step 1, I'll find the sum. To find the sum for such fractions, I showed you already, or we saw a question where I have to make the denominator common, and then my numerator simply become the sum of the denominators because they multiply with 1. So beta plus alpha or alpha plus beta, it is the same thing. Okay, because I showed this already, that is the reason I'm being quick. And now you plug in the values. Alpha plus beta, we already know it's minus b upon a and c upon a. What happens? The common denominators, they cancel out from both part of the fraction, right? All you got as the sum here is minus b upon c. Okay, and trust me, if I'll do it this way, you will understand how exactly the shortcut works. Okay, there is a shortcut, as I'm saying again, and I will show you how exactly that works. It's really interesting. And now the fact is, once I have found the sum, I need to find the product. So I know how to find the product here is to take the roots, whatever they have told me to consider. Their product is simply 1 upon alpha beta. 1 upon something means reciprocal of alpha beta. So 1 upon c upon a is just the reciprocal of c upon a, which is a upon c. Again, we found the sum of zeros, or sum of 1 by alpha plus 1 by beta, and we found the product. Once I know the sum and the product, what should I do? I will write the quadratic x square, take the sum in the opposite manner. So if I'll take the sum negative of the given value, it gives me positive b upon c plus the constant a upon c. And now again you multiply everything by c. Okay, that is how we get the term. We multiply everything by c, then your expression becomes, so you can write it as a equation again, ax squared plus b by c plus a by c is equal to 0. We multiply the whole equation by the denominator c. What happens? Cx squared plus, I missed to write this x here, sorry. So cx squared plus bx, because the denominator cancels out with the new multiplier c that I've used to multiply each term. Similarly, this becomes a. We got the quadratic cx squared plus bx plus a equals to 0. Now what is the shortcut? The shortcut is just swap the position of the leading coefficient and the constant. Check it out. Isn't that interesting? I've actually made a lot of shorts based on this, where they ask you, this kind of question is there in some competitive exams. I cannot recall which exactly that was, but you have questions like this where they ask you to find the zeros of a quadratic polynomial, find the quadratic polynomial whose zeros are reciprocals of the zeros of a different polynomial. So the concept is to just swap. The shortcut is to just swap the value of the leading coefficient with the constant. Everything else is same. Okay, so they'll give you in your competitive exams, they'll give you, like, if the equation is 2x squared plus 3x plus 4 and find the quadratic whose zeros are the reciprocals, all you have to do is just swap this 4 and 2 to the other side. Like, it's so easy. I didn't know this before. All right, yes, you are right. You are telling me that they have given you polynomial. So here, why am I writing it 0 is because I want to divide everything by c, the common multiplier c. If not, I mean, even if you write it equal to 0, it's not wrong, okay, because it is the standard way to leave a quadratic. If you want, then obviously you can write it in terms of k, or you can write in terms of that c as a multiplier outside. Okay, that is also there, but my suggestion is, because they are asking you a quadratic polynomial, in the question they have given you fx equals to something, so you can write it as px equals to cx squared plus bx plus a. If you don't want to write 0, I mean, even if you write it, that does not make anything wrong. You can write it as a new polynomial, so maybe you can write it as px. Okay, all right. It is like, you know, because the standard way we leave a quadratic polynomial is, I mean, with equal to 0. So because they told you to find a quadratic polynomial, so instead of not writing 0, we can write px. We can name that polynomial as px and say that it is equal to this. Yeah, this is an easy question, but there is these set of workings you have to show if you want to fetch that full 3 marks. Okay, don't go ahead and use the shortcut. The shortcuts are only for the competitive exams. All right, I hope that made sense. We are now doing the last question of this topic. If alpha and beta are the zeros of the polynomial 3x squared plus 5x plus k such that alpha squared plus beta squared plus alpha beta is 19 upon 9, find the value of k. It's for 3 marks. Now, likewise that we have been doing for all questions, what we really need is the sum and the product of the roots or zeros for the given polynomial. So for the given polynomial, you can find out what's the sum of roots or sum of zeros is just negative 5 upon 3. Alpha beta is simply equal to the product term divided by the leading coefficient 3. And now because my equation is given in terms of alpha square plus beta square, I can obtain that clearly by simply taking the two values. Alpha square plus beta square can be written as alpha plus beta the whole square minus twice the value of alpha beta. Okay, let's put that directly into the equation. So instead of alpha square plus beta square, I will write down alpha plus beta the whole square minus 2 alpha beta is the way I'm representing just this part, the sum of the squares. And I have the existing term alpha beta, which is equal to 19 upon 9. I hope that made sense. I'm using this equation. I substituted this by the identity, okay, and then I kept this plus alpha beta as it is. And now I have the values of each of the things that I have. Alpha plus beta the whole square, I know the value of alpha plus beta, which is minus 5 upon 3. So minus 5 upon 3 the whole square. Outside I have two like terms, minus 2 plus 1 is minus 1. So I will keep that as minus alpha beta. So minus alpha beta, we got the value, minus is just out, so minus k upon 3. I hope that made sense. All I did is just evaluated this part together. This is minus alpha beta and just plugged in the value of alpha beta with that negative outside. And now this is equal to 19 upon 9. I have to square this, so square of minus 5 is 25, square of 3 is 9, minus k upon 3 equals to 19 upon 9. Again, the variable term is negative. You swap the position with the constant other side. Swapping position means the new term that comes this side also becomes negative, while k upon 3 goes to the other side to become positive. I have two like terms to deal with. It's very easy. 19 subtracted from 25 is 6. So 6 upon 9 equals to k upon 3. So k has to be 6 and 9, both are reducible, 2 and 3. Now because I have the same denominators, 3 and 3, we can cancel them directly like this and gives you k is equal to 2. How does that look? We just got the answer k is equal to 2, and this is the exact way you could approach this question with minimal steps. Was that easy? I hope so, because this is exactly the kind of questions you can expect for polynomials, and with these many questions, if you practice this much of questions for polynomials, okay, I'm very confident that you will have no issue with dealing any questions in your pre-boards or even boards. All right. It's actually no problem. It's a good thing that you had a problem now, because I know you will not have the same problem again. I always tell this to my students, it's okay that when you're starting with me, you are having more problems and more mistakes. I'm glad that you're making mistakes now, because I know you will not repeat it later. That is what I tell them. And no problem, Rohit. It is something that if I had been in your place, I might have gone more than one question wrong. Okay, so it's not that I don't think, wow, Rohit, you score 14 out of 15, not bad, right? It is good that you were able to score, like you were able to do a lot of questions. The last one was definitely more challenging. That is the reason I kept it for the last. Okay, and definitely this is how you can approach different questions. I'm hoping that they might not ask you so complex questions now, okay, because now CBSE is trying to keep things more, easy than what we used to have before. Okay, so but having said that, it is always good to challenge yourself. Okay, I have a lot of questions from quadratic. I do with many different curriculum. Like in different curriculum, when I do them, the questions are very tricky and more complex, but I'm not teaching you all of those, because I know you will not be tested on any such questions. But this reciprocal concept that I told you, okay, the shortcut is my favorite thing, because I didn't know that before, honestly. And I just recently started seeing that identity, how it worked out, and it can be very helpful for Alan. Okay, that question where I discussed about reciprocals, it is very helpful, because you will see a lot of questions like that. Okay, and with this, we are done with polynomials. Polynomials, it is done. The topic is done. And as you suggested, Rohit, I will take that as a feedback, and I will go ahead with a lot of challenging questions from multiple topics. And I'll also take care of the competitive questions, past paper questions for Alan, because he is preparing for a competitive exam. I hope you will give your best. And when is your exam, by the way, Alan? Like which month? Do let me know, because I can help you with multiple topics. I can also plan things accordingly. Okay? Yes, sure, you're welcome. And let me know the topics so that I can set questions ready for that. I am also planning to go live on algebra, like algebra all level. It can be for everyone, school students, competitive exam, mainly for competitive exams I'm dealing with. Okay, I will make sure that I consider all past questions, and please let me know whatever things you need. I'm here to deal with your math problems. That is the least thing I can do. I will deal with all the problems you have, and with this, I will end today's session. I hope you understood, you enjoyed it. The time was valuable. You learned a lot from this. I hope so. Okay. All right, wish you the best, Alan. You have time, so start preparing early. Rohit, yes, I do teach science, but not online. I do teach some of my students, like students who study math with me. I teach them science, mainly chemistry. I teach. Thank you, Sai Waller. I also appreciate the fact that you are interested in learning and recapitulating whatever you studied before. It's something that not everyone is interested in, especially in this age of, like in this era of all reels and everything, people coming to study maths, even though it's like not like something mandatory for them. That is something I really appreciate.